Hi, I'm Harvey Hamilton from Oakville, Washington. Today we're going to look at an engine rebuild on a John Deere 3010 diesel engine. This is the first part in a complete tractor restoration. Before we get going on that, I'd like to tell you a little bit about myself, my business, and my experience as a mechanic. I grew up on a farm in southwest Washington. My grandfather purchased the farm in 1945. My family worked the farm while I was growing up, and in the early 90s, I went to work for a local dealership as a mechanic. While working on the modern machinery at the dealership, I realized that my interest was going more and more towards the vintage tractors. So I established my own business, Tired Iron Restoration. At Tired Iron Restoration, I repair tractors for local farmers, and I restore tractors for people nationwide. Although I restored many tractors for collectors around the country, this will be the first tractor that I've done for myself. This 3010 was a tractor that my grandfather bought in 1968, and it was our primary tractor on the farm for many years. My grandfather taught me how to plow, how to bale, how to do a lot of the farming chores that we did while I was with him on this tractor. It's a special tractor to me, and we're going to restore this tractor, first the engine, then the other components as we go. I've already removed the engine from the tractor. It's mounted in an engine stand and it's ready. Let's go up to the shop and get started. Before we really get going on this project, I want to encourage you to get all the manuals, all the information that you can on hand and at your disposal before you start. I have here a technical manual that shows the breakdown and repair of each and every component of the tractor. I have an owner's manual that shows periodic lubrication, maintenance, and operation of the tractor. A lot of information in an owner's manual that you won't find anywhere else. So it's good to have one of those on hand. A part manual that shows the breakdown of all the parts, their relationship to each other. I like to have these. I refer to them probably more than any other manual because a lot of times these old tractors have pieces missing, and when you are able to locate a part that's not even on the tractor that you're working on, that's good. It'll tell you the length and number and size of bolts. That's very handy. So it's good to have a part manual. They're almost indispensable. Any other component technical manuals that apply to the tractor? In the future, we're going to be using this radial piston pump manual. It's a component technical manual. And as we rebuild this engine, we're going to use the diesel fuel system manual, component manual. That'll show us how to rebuild the injectors and the injector pump. So make sure you have every publication that it applies to your tractor. We've got ours assembled here. We're going to be using almost everything while we rebuild this engine. So get them before you start, and good luck with your project. So first, let's take a look at the engine itself. This engine was taken out of a John Deere 3010. It is a 4-cylinder, 4-stroke, naturally aspirated engine that is water-cooled. Radiator, thermostat. Here's the diesel fuel pump with the injector lines that go up to the individual injectors. This is a 4-cylinder engine, and it is set up here temporarily so that we can run it on the engine stand for the evaluation of the condition of the engine. Now that we've identified the components on this side of the engine, let's spin it around and get a look at the other side. The components on this side of the engine are, again, the lower radiator hose, top one, better view here. This is the thermostat housing. Thermostat sits right in here. It regulates the temperature of the engine. When I talked about it being a naturally aspirated engine, all that means is it does not have a turbocharger. So the engine pulls via the intake manifold here, pulls the intake air in through the filter into the engine via the vacuum of the intake stroke of the engine. This is the exhaust manifold, muffler. Down in here is the starter. This happens to be a 12-volt starter. This tractor was produced new with a 24-volt system. It was altered to a 12-volt. We'll change that when we get to the electrical video. And then down in here on the front side of the case of the block is a positive crankcase ventilation pump. It actually pumps air into the crankcase so that there's positive crankcase ventilation. Now that we've moved to this section where we're going to evaluate the engine as it's running, we've opened the doors of the shop so that the smoke will get ventilated to the outside. A couple things I wanted to show you before we got started though was this engine's mounted on an engine stand, and so there's a couple things that you'd have to deal with that you wouldn't normally while it was on the tractor. If this is mounted in the tractor, the flywheel will be contained inside the clutch housing and you wouldn't have to worry about the rotating flywheel. Here I've made a screen to go around it to prevent getting tangled up in the flywheel as it's rotating. Same thing for the fan up here. Typically it would be contained behind a shroud and you wouldn't have to worry about it. But I built a screen to keep accidental entanglement with the fan and also the fan on the alternator. So now that we mentioned the safety aspects of what we're doing here and that we're safe when we start the engine, let's go ahead and start the engine. But I want to tell you first of all what we're going to be looking for as the engine runs. First of all, we're going to watch what comes out the stack as far as the smoke. Is it blue? Is it white? What exactly is coming out the stack? That gives us an idea of how the fuel's burning, if it's timed properly, those sorts of things. Secondly, we're going to look for oil pressure here on this gauge. It's plumbed into the port where the oil pressure sender normally sends the pressure to the gauges. And third, we're going to listen to the engine to see how smooth, rough, whatever we're getting out of the engine. It's an old engine, hasn't been rebuilt for a long time. It needs an overhaul, and so let's just run it and see what we come up with. We're going to start it up now, but before we do, I want to make sure to encourage you to wear your eye protection and your ear protection anytime you're working in and around an engine that's running. Let's see what we got. Okay, we ran the engine once, and a couple things I've noticed with the injection pump. First of all, when you start it up, first off, if you don't give the throttle just a little bit of a jar here, the engine wants to run away. It wants to take off and accelerate. And so that's one problem. I suspect there's a metering valve problem inside the pump. The other one is that as the engine's idling at a low idle, it wants to hunt for an RPM in which to idle at. So you can hear the engine up and down, up and down, up and down. I suspect that there is a governor problem. On diesels, the governor is inside the injection pump rather than up in the front. So we got some problems with this pump, and I just want to illustrate that in a quick restart here. We'll see what happens when I don't touch the throttle right at first. Now that we've talked about the specific problems that I noticed with this injection pump, I really want to encourage you as you diagnose and evaluate your tractor, your engine, not to rush through this phase. We know we got a problem here, but if we rush into it and repair this and we don't find any and all of the rest of the problems, we would only have a partial job. So we're going to start it up again. We're going to take another look at the smoke coming out the stack, and then we're going to talk for a minute about the different colors of smoke and what those problems may be. This engine smokes just a little bit to the blue, a little bit of blue smoke coming out the stack. That's typically burning oil. And those issues are valve stem leakage, cylinder rings, piston ring leakage. And we'll get an idea what exactly is wrong with this engine when we go in and do a compression and a leakoff test. We'll be able to nail down those problems exactly. I want to talk to you a little bit about the other colors of smoke that you may notice in your tractor. White smoke is typically unburnt fuel. It's usually a timing problem. Either you have late injection of the fuel, and so there's a portion of unburnt fuel in the emissions that come out the stack. That's typically what it is for white smoke. Black smoke is overfueling that you'll find from a couple of problems. Either your pump is putting out too much fuel, your injectors are putting fuel in that's not atomized to the point that it can burn, or the other one is a clogged air intake system. When you have too little air and too much fuel, you get black smoke. And that's the three colors of smoke that you'll normally find. Those are the typical causes of those colors. Blue smoke is oil, white smoke is fuel injected but not burned because it's injected late, and black smoke is too much fuel for the amount of air that's in the cylinder. Our next step in diagnosing this engine is to do a compression test. And in order to do that, we'll need to remove the injectors and part of the fuel system components. We'll also remove this protective screen so we have access to the timing marks on the flywheel so that we can compare the timing marks on the flywheel to the timing marks on the injection pump. And we'll show how those things line up. I've installed this piece of metal here that is an exact line to the hole, the inspection hole, or the timing line in the clutch housing. That gives us a line so that we can, even though this engine is not mounted in the tractor, we still have a line in order to compare the timing marks on the flywheel to the timing marks on the clutch housing. We're going to position the crankshaft at top dead center and observe the fuel timing marks on the fuel pump right here. This particular pump on this engine has right here an advance capability inside the pump, where the faster the engine goes, the pump will advance the timing and inject the fuel just slightly sooner the faster the engine rolls. So when an engine is equipped with this feature, or the pump is equipped with this feature, the manual says that you set the timing, the static timing, at 4 degrees before top dead center. So as I roll the engine into counterclockwise on the flywheel, standing behind it like this, as I roll the engine into that position, 4 degrees before top dead center, that means that the number 1 cylinder is on top dead center. The flywheel is 4 degrees before top dead center, which is here, and then the pump should be statically timed when we remove this window. So we'll go ahead and do that now. So with the flywheel set at this position, there's 2 marks in here. One is on a stationary rotor, the other one is on a rotor that turns and comes into view as you position that here. So we got the fuel tank and some of the small pieces off. The next thing we're going to do is remove this fuel filter right here. There's a drain here that will actually drain this cavity so that the fuel doesn't spill down the engine. Then we're going to take off the injector lines at the pump and at the injectors all the way across here. Take that out as a unit. Then the return line across the top. That'll give us access to each individual injector, and we'll be able to pull off the mounting clamps here and lift the injectors out of the head. That's what we need to do in order to have access to put in the test equipment for compression test. The bolts and sealing washers that hold the high pressure lines both onto the pump and also onto the injector here have a small sealing washer, one behind here and one on the outside here to seal against the line. The bolt itself has a hole in it where the fuel goes in here and then into the injector through this part right here. These little steel washers are non-reusable, so each time that you loosen or take these loose, you'll have to replace the washers. Each injector is held in by one bolt with a clamp that just exerts pressure down on the injector itself. So to take them out, it's just a simple matter of loosening the bolt, taking it out. The bolt is fairly long, so once you get it up just a little ways, a lot of times you have to pry the injector up some to get it loose and then take the bolt out the remainder of the way. These are the nozzles of the injectors. They're almost impossible to see, but in the tip of each one of these injector nozzles is some small holes that the fuel sprays out of. These are covered with carbon, and they'll need to be cleaned up. They'll need to be resized, or possibly even the whole nozzle will need to be replaced. There's a small copper washer that goes on the injector right there that goes down into the bore and seals against the head. Getting ready to remove the injection pump now. I've removed the two mounting bolts down here on the base. We've got number one at top dead center. 4 degrees actually on the flywheel because of this advance on this particular pump that calls for 4 degrees instead of top dead center. It's important to consult the manual to get the exact timing for your particular tractor, your particular model. We're going to go ahead and pull it out. I want to show you a couple of things. The base of the pump is slotted to allow for some adjustment in timing. This is the drive lug that fits into the oil pump gear, and it's built in such a way that it only goes in there one way. Take a look down inside and we'll show you the position of the oil pump gear as it's supposed to be, as number one is timed top dead center. Here's a look down through the hole in the block to the top side of the oil pump drive gear. These are the slots that the injection pump meshes into, and this is the position that we'll be looking for when we reassemble this engine. We'll want the V mark positioned towards the cylinder block of the engine, and we'll want, with the reference of these white lines here being straight between these studs, we'll want the slot to be at an angle about 15% or 15 degrees off of this straight line. So this is the view. This is what it'll look like when we reassemble the engine as well. It's always good to take a look at your timing marks as you disassemble the engine. It gives you a visual picture of what the manual's trying to tell you about timing when you reassemble. Okay, getting ready to do a compression test. These are the tools that we'll use to read the compression of each cylinder. We've got the engine warm, we've got the fuel system removed and out of the way, the injectors are gone. So we can install a compression testing fitting into the place where the injectors were. It's a hollow tube that comes up to a quick coupler and a check valve here. This attaches to it and it reads the pressure. We have a 600-pound gauge. Our compression for this particular engine on a new broke-in engine would be 450 to 475 pounds. So we'll go ahead and install this. We'll use one of the clamps that holds the injectors down to hold this fitting down, and we'll take a reading off it, see what we have. So we got the test equipment in. We're going to crank the engine over at cranking speed, and we're going to measure the pressure that builds up. We'll roll the engine probably 10 compression strokes or until the needle on the gauge stops moving, and we'll take a reading. We'll take a reading in each cylinder, and then we'll compare them and see how close they are to each other. I like to do the pressure test twice and then make sure that both numbers are the same. So we'll release the pressure in the gauge. 380 again. I think we can rely on that number for this cylinder, 380 psi. in number 4 cylinder. Okay, number 3 cylinder. Not so good. This one measures 260. I'm going to make sure that we have got a good seal between the testing unit and the cylinder head here, just to verify that we don't have any compression leaks. And this one tested really low, almost 100 pounds, a little over 100 pounds lower than number 4. So we're going to make sure we don't have any leaks there, so that it causes us to get a false reading. Just recenter that. Let's try one more time. We have about 360 on this one. That's a lot better. We must have had a compression leak on the first test. We'll release the pressure and do it one more time. Our specification for this engine is 450 to 475 on a new engine. So we're reading about 100 pounds less than the top end of the spec. So we'll compare each cylinder and look for variation between all 4, as well as low pressure. $375. That compares only 5 pounds less than number 4. That's a good number. That's consistent. We're going to measure cam lift right now, and what we determine by measuring that is how much wear the cam has experienced over the life of the engine. The specification for this engine is 0.430 to 0.460. So we have a range of 30 thousandths that the cam can be worn. The first thing to do is to set, we're working on number 4 cylinder right here. So we set number 4 at top dead center. So both of the rocker arms are completely loose. They're on the lowest part of the cam lobe. And we measure with a feeler gauge. The specification for valve adjustment is 18 thousandths. So we measure this valve, 18 thousandths slips in there just right. This particular one is adjusted right. So that's the first thing to do before you actually measure it. Second thing is to set up the feeler or the dial indicator on the engine. This has a magnetic base. It comes down, and the dial indicator can then rest right on the top of the valve on this side. So once that's all set and we've zeroed our dial indicator here, we can turn the flywheel and we can measure the amount that the cam lobe depresses the valve. So right there we've got the lowest part, the furthest down the valve is going to go, and according to the dial indicator we have 0.440. So we're 10 thousandths above the lowest minimum specification for this cam lobe. We'll go ahead and do that for every single one so we know the condition of every lobe on the camshaft. So we've completed the compression check. We went back and checked number 2. All the cylinders are within 5 pounds of each other. That's really good. but they are all consistently about 80 to 100 pounds below the specification. So we're going to proceed on now to a leak-off test. In order to do that, we're going to need to remove the rocker arm cover and then the rocker arms so that all the valves are seated in their seats. That way the air that's pumped into the cylinders won't have anywhere to escape except past the valves or past the rings. We'll be able to tell whether it's the intake valve leaking, the exhaust valve leaking, or the rings on the piston leaking, and where we're losing our compression. So let's go ahead and do that now. These are the rocker arms. They transfer the action of the camshaft through these levers to the valves and depress them according to the right timing of the engine, according to the lobes on the camshaft. We're going to go ahead and remove the push rods. These are the rods that transfer the motion of the camshaft up to the rocker arms and to depress the valves. And so we're going to take those out before we do the leak-off test. So we're ready to do a leak-off test in cylinder number 1. By injecting shop air here through a regulator, past these two gauges and into the cylinder via the same fixture that we used for compression, we'll be able to measure on the first gauge the amount of air pressure that we're putting in, and on the second gauge, the amount that is remaining in the cylinder. So thereby, by subtracting the percentage, we'll be able to find a percentage of leak off. So as I increase the air pressure, to 100 pounds, we can read on this gauge that we're holding about 93 pounds, so we have about 7% leak off in number 1 cylinder. That's a really good number for that cylinder, and we'll proceed on to check 2, 3, and 4. We have about 8% leakage on number 2 cylinder. 100 pounds here, 92 pounds over here. I can test now to see where this air is going, the 8% that's leaking out. I can lay my hand over the exhaust manifold and listen and feel for air buildup. I don't have any. Could do the same thing for the intake manifold. Very little on this. And I can hear air down inside the crankcase. So we can assume that the air that's bypassing in number 2 cylinder is bypassing into the crankcase. We've ran the engine, it's warm. This is about as good as it's going to get for this engine. And there's air going into the crankcase. So we do have ring blow by in number 2. We had the same thing in number 1. We'll proceed on now to test 3 and 4. Okay, we got the leak-off test going here in number 3. We found a place in the cylinder where it won't hold very much air. But if I wiggle it a little bit, there's something going on possibly with the rings or something like that where it'll hold about 20%. The other two were less than 10% leak off. This one's 17. So we have, at least in the position that the piston is in right now, we have a bit more leak off. So that's something we'll check when we get in there, try to determine what is causing this problem, and take a look at that point. Number 4 cylinders holding about 96%. Only has about a 4% leak off. And what I do here leaking off is coming again past the rings into the crankcase. So we finished the leak off test on this engine. We experienced between 2 and 17% leak off in various cylinders. A typical engine that is in really dire need of rebuild would sometimes have 20, 30 or more % leak off in a particular cylinder. Those values might include leakage from the intake and exhaust valves as well as the rings on the pistons. We're going to take this plate, this cover off right here. It's kind of a multi-faceted thing that goes on here. There's a gear in here that drives the tack for the tractor. There's behind that, there's the gear on the oil pump. It drives the oil pump. That drives off of the camshaft. We're going to take a look at the condition of those gears and get an idea if we're going to need to replace our camshaft or not. This screw right here is how you adjust your oil pressure for the engine. So by taking this cap off here, there's a jam nut and a small screw that you can move to adjust the oil pressure. We'll do that when we reassemble the engine, but right now we're going to take off this cap to look at those gears. This gear drives the tachometer, and when you take the whole thing apart, this flap, this spring-loaded flapper right here, rests on this hole when it's together and regulates the oil pressure to the rest of the engine. Part of the oil from the pump will bypass this spring-loaded plate, and thereby the more oil that bypasses, the less oil pressure you have. The more that, or the less that bypasses, the more oil pressure you'll have. So that's a very simple oil pressure regulating system. Right through this hole, we're looking at the oil pump drive gear, and we're checking the condition of these teeth along this edge here. A drive gear that's really worn will have very little left on the top of the gear here. See how we have a flat surface along here? That is a gear that's in really good condition for the age of this engine. A really worn gear would be almost razor sharp at that point, and there wouldn't be hardly any flat surface left here at all. So I'm satisfied with the way that gear looks. I think that at least that much of the oil pump is in good condition. The corresponding gear on the camshaft in the back that's hard to view at this point. We'll look at that a little closer later, but typically those gears are similar. So we have a good gear here. I'm confident that we'll have a good gear on the camshaft itself. Let's review for a minute the cooling system on this engine. Cooling system consists of a radiator, hoses, top and bottom, thermostat, and a water pump, along with a fan to move air through the radiator itself. We've already drained the water out of this radiator, so I want to talk to you a second about the radiator. Things you should look for. You want to look to make sure that you can see through the fins of the radiator. A lot of times working in the field will pull dirt into the radiator, chaff, other things, and it'll clog the core of the radiator. So first thing you want to do is make sure that you have a clear all the way through radiator. Second thing is you'd want to take this to a radiator shop, and you would want them to test it for flow and also to pressurize it to make sure that it would hold water under a normal pressurized system. You want to check your hoses to make sure that the rubber isn't soft and starting to deteriorate. Since this is a restoration, we're going to be installing a new radiator hoses, and we'll also be rebuilding the water pump. But we'll go over that as well in just a minute. So let's take off the radiator and the hoses. We've removed the radiator, and so we can get a better look at the fan, the pulley, and the water pump just in behind. These are the components that pump and cool the water in the cooling system. There's a bypass tube that comes off the water pump up to the thermostat housing. We remove that. Just under it is the thermostat. The thermostat is what controls the temperature, keeps the temperature of the engine at about 180 to 200 degrees. The thermostat is that controlling valve. A sticking thermostat will cause an engine to overheat. That's one of the first things to look at if you've got an overheating problem. Second thing is to look at the water pump to make sure that the bearing and the seals are not worn out. And we'll do that in just a minute. Okay, we're just going to quickly drain the oil out of the oil pan here while we're doing a couple other things and just let it drip so that the oil pan is completely empty. Before we remove the water pump, I want to show you a way to determine whether or not the bearing is starting to go out inside the shaft that drives the impeller on the pump. All you need to do is take the fan and wiggle it back and forth just a little bit. This one is starting to deteriorate. I can feel and hear a small clunking noise as I move the fan back and forth this way. So this pump will get rebuilt anyway, but we know that it's not going to last too much longer the way it is. We're going to remove this 12-volt alternator from this tractor, and when we reassemble everything, we'll install a 24-volt generator with a 24-volt regulator and also a 24-volt starter. The tractors were originally produced with 24-volt systems, and at one point, to simplify things, a kit was available to make the entire system into a 12-volt system. Since we're doing a restoration, we'll put it back the way it originally came from the factory. We've rotated the engine up a little bit so we can get to this front pulley with the engine stand. And right now we're going to pull off the front pulley on the crankshaft. We're going to go ahead and put a puller on here. I've installed a 5/8 bolt in here that I've drilled a small indentation in the head of the bolt. And that'll accept the tip of the puller so it doesn't slip off. Just install this here. This is the front timing cover of the engine. Underneath this are the timing gears that are on the crankshaft, the camshaft, and also the gears that run the crankcase ventilation pump. First of all, I want to talk about this engine oil seal here on the front. This is called the front main seal, and you can see the bit of grease around here that shows that this has been at least seeping a little bit and needs to be renewed. I've taken the bolts out around the cover. Let's take it off and see. The timing gears on the front of this engine, there's 4 of them. This being the camshaft drive gear, the crankshaft drive gear, idler gear, and the crankcase ventilation pump drive gear. These 2 gears do not have timing marks on them and are not important to be timed in any specific way. The crankshaft and the camshaft, however, have marks on the teeth, and they're very important that the relationship between the 2 is correct. The camshaft gear is twice as big as the crankshaft gear. So the crankshaft has to turn twice for the camshaft to turn once. We'll demonstrate that here. On the first revolution of the crankshaft, the timing mark has come back around. The timing mark on the camshaft is over here, exactly 180 degrees away. On the second revolution of the crankshaft, the 2 marks line up once again. This idler gear and this drive gear on this engine are not timed because there's no necessity for these to be in relationship to the rest of the engine. They're just pump. This is just a pump gear and this is just an idler gear. On some engines, this gear in this position would drive an injection pump. On this engine, the camshaft drives the oil pump, which drives the injection pump. So again, it's very important for these 2 marks to be lined up. We'll talk about the other timing marks again in the future. I think it's always important to take a look at your timing marks when you disassemble an engine. It gives you a visual of what things should look like as you put it back together after everything is fixed. And it also can tell you, possibly some assembly problems on a previous rebuild. Sometimes things are not done properly before you do. So it's always good to go back and look to make sure that everything lines up the way it should. This is a diesel fuel nozzle tester. We've got the injector hanging here, plumbed into the line. This handle is a pump that injects test fluid through the injector, and this gauge meters the amount of pressure that it takes to get a spray pattern out of the nozzle. 3 things that we're going to look for as we pump up the pressure in this nozzle. Number 1, we're going to look for an even spray pattern with a distinct chirping sound that comes from it. Number 2, we're going to look for a pressure on the gauge. In this particular injector, the specification is 2,400 to 2,600 pounds. And we're going to look for that pressure. Third, we're going to look for whether or not when the pressure is held at that level, whether or not the injector dribbles or drips out the end of the nozzle. A couple of things I notice about this injector. 2,400 pounds is where this one pops off or injects, and that in and of itself is not a bad pressure. And if that was the only thing that was wrong with this, we'd be completely satisfied with it. But when we hold it at 2,400 pounds, it dribbles or squirts out the end of the nozzle. We've got problems in here. That's not a good spray pattern for a good diesel engine, and so we're going to send it for repair. We're at a point now where we can take off the exhaust manifold, the intake manifold, the vent pump, and the starter on this side of the engine. Also the water manifold up here. So let's just do that. There's a special tool that helps take off the bolt in behind on this starter, and it's just shaped like this. You can order it. Goes in behind here and works back in this. There's no common tools that'll reach that bolt. We're going to remove the pressure plate assembly from the flywheel and take out the clutch disc. There's 6 mounting bolts around the circumference of the pressure plate. We've taken out 4 already, 2 more, and we'll pull the pressure plate off the flywheel. This is the traction clutch and the flywheel. The flywheel is very dirty, has a lot of rust and debris inside of it. We'll need to clean that up, possibly have to surface the flywheel itself at the machine shop. We'll deal with the clutch and the pressure plate and all the components of that in a powertrain video. But for now, we're just gonna, on this video, we're gonna talk about the flywheel. We're gonna deal with the flywheel because it's actually part of the engine. This is the clutch surface of the flywheel. It has some grooves worn into it and a little bit of a ridge where the clutch disc has been running. So we'll take this to the machine shop and we'll have this surfaced. They'll take off, if they take off 10 thousandths in order to smooth this surface up, they'll have to take off 10 thousandths here as well to keep the relationship between this surface and the mounting surface for the pressure plate the same. In the center of the flywheel is a pilot bearing that accepts the input shaft to the transmission. It's supposed to turn freely on the inside, but right now it's not moving at all, or just slightly in one little area. So it's rusted or seized up. We'll need to replace that. We usually do on a clutch job anyway, but that bearing needs to be replaced. But what I want to show you is how to pull it out. This is a 5/8 bolt with the head ground off of it, so there's just one side of the head left. So it forms a little hook. That works really good attached to a slide hammer. You just slip it inside, catch the inside of the bearing, and pound the bearing out. I'm going to remove the flywheel from the end of the crankshaft. Flywheel is heavy, so make sure you have a good grip on it when you work it loose. There's 2 dowels on this one that dowel and position the flywheel to the crankshaft. You just work it loose from that and then take it loose. This housing here, these bolts around here, hold the rear main seal of the crankshaft. This is the crank, spins here, and this is the seal around here. You can see that there's some wet oil coming down here at the bottom, and we noted that crankshaft seal is leaking. So if a person was going to do a clutch job on a tractor and they got the flywheel off and they saw a situation like this, you would want to change the rear main seal at the same time. This is, of course, an complete engine overhaul, so we'll change that as we put it back together. Here we're pulling out the head bolts. Each head bolt has a hardened steel washer on it that needs to go back with it when this is reassembled. So make sure that each bolt keeps its washer as you take them out. Sometimes they stick into the head and you don't realize it and you'll lose them at some other time. Getting ready to take the head off. The head is really heavy, so it's advisable to get some help to lift it off so you don't hurt yourself or damage some of the engine parts. Especially if you're working on a 6-cylinder engine. This happens only to be a 4, not quite as heavy, but still good idea to have some help. Now that the head is off the engine and on the table, before you remove the head gasket, before you scrape any of the carbon, do any cleaning or anything, it's a good time to inspect the head for clues to how the engine was running. You'd want to inspect the head gasket to make sure that there were no breaches between the fire ring and any of the water ports or oil ports on the head gasket. This one looks good, no problems that we can see. Another thing you would want to look for is examine the valves, the face of the valves, to see if there's any pitting or burning along the edges. Again, these valves look good, no problems with that. And then you would want to examine the carbon, the telltale trails left by the carbon. This is number 1 cylinder and it's very dry. It's dirty, it's carbon, but it's very dry, no signs of wetness or uncombusted fuel. This is cylinder 4 here, and comparing the carbon and what we can see from this angle here on this cylinder, we see a lot of wet around this intake port right here. It could be some oil, could be uncombusted fuel that's making this damp here. But we can, by looking at the comparison between each cylinder, we can tell a lot about how the engine was operating. We're going to go ahead and take the valves out of the head now. We're going to take a closer look at those. We'll measure them. We'll try to get a sense about the valve stem to valve guide clearance, and we'll examine the face of the valves themselves. This is a valve spring compressor. We'll use it to compress the valve springs and to remove the keepers so that the valves will be released from the head. We're going to measure the clearance between the valve stem and the valve guide. A quick way to do it really easily is if there's a lot of clearance, you'll be able to move the valve back and forth in the guide, and it'll seem excessive. This one seems fairly tight. I suspect that we'll have good numbers when we measure this valve. Use a caliper or a micrometer to measure the valve stem like this. Our specification on this valve is supposed to be 3.715 to 3.725. Right there, we're measuring 3.72, just a little bit over 72. So this valve is, the stem itself is okay. The next step would be to use a little poppet gauge to go inside the valve guide and measure the inside clearance in there. So you compress the deals, tighten it down so they don't spring out, insert it into the valve guide, loosen it, move it around till you get a good center on it, tighten the tightener down, pull it out. You should have, with this poppet gauge, a representation of the inside of the guide. So now we measure the inside of the guide, and we have 3.75, which gives us a difference of about 3 thousandths. The book says that we need to replace the guide and or the valve when the clearance exceeds 6,000. We have 3 thousandths clearance, and that would be a good measurement. The remaining thing that we need to do when we look at a valve is to look at the margin between the angle of the face and the flat part of the head of the valve right here. A new valve will have a fair amount of margin there. This one has been ground before, and it's almost knife-like at the edge. Even though we had okay clearance between the stem and the guide, we would still condemn this valve as being no good because of the margin at the head of the valve right here. The valve seats are a replaceable item in the head itself right here. This being the exhaust, this being the intake. If we have to replace them, we can do that by taking the old ones out and putting new ones in. Or if that's not necessary, then the seat itself will be reground to the same angle as the valve. And then when you put the two together, it provides an airtight seal when it closes. This being the intake, every time the air comes in, the valve closes for the compression stroke of the cycle. The last thing we're going to do is to measure the valve recession, the amount the valve face recedes into the head from the top of the head here. In order to do that, we set up the dial indicator with a level foot on the bottom, and we're able to run the peg down to the valve and measure how much it is below the surface of the head. This particular one measures 67 thousandths below the top of the head. The published specifications for this head are 30 to 50 thousandths. So it would be impossible to reuse this valve the way it is because it allows too much extra space inside the combustion chamber. We're going to pull the cam followers now. The cam gear being here, the cam runs along this side of the engine. Through these holes are where the push rods come up to the rocker arms on the head. So down inside here are the cam followers. Just takes a simple magnet, reach inside, and withdraw the cam follower. A visual inspection of the cam follower, you would want to look on the sides of the cam follower for scoring or wear marks that would be excessive. You should be able to feel it if it's bad, where it rides up and down on the block inside the engine. And then also on the flat surface that rides the lobe of the cam up and down, you would want to look for wear marks that the cam left in this surface of the cam follower. These can be machined flat again, and we'll do that in the machining phase of this engine.